Hi, everyone. So I hope you can all see me and hear us. And if you can, maybe give us a sign in the chat. My name is Roxana. I'll be your MC for tonight. Just a few sentences about myself. I'm a cognitive data scientist, and similar to Jonathan, I also situate myself between interfaces of fields. So I'm really happy to be emceeing this talk. And with no additional comments, it is my pleasure to introduce Jon Peck, a full stack developer with 2 decades of industry experience who constantly strives to make technical concepts digestible. What should academia do every day, but it doesn't. Demonstrating the value of new technology at every level, from developers for execs. A really impressive CV, former speaker at Developer Week, OSCON, AI Next, O'Reilly AI, ODSC, API World, developer and advocate at Mass General Hospital, right up my alley, Cornell University, Algorithmia, and currently technical advocate at GitHub. And I will be moderating the chat, so please don't hesitate to post any questions you have throughout. I'll keep track of them, and then we'll take those up at the end. Take us away, Jon.
Hey, thanks very much. Appreciate the warm intro. So hi, yes, I'm Jon Peck. I'm technical advocate at GitHub right now. If you want to connect with me, please feel free to reach out at PeckJon, that's P-E-C-K-J-O-N, on Twitter, LinkedIn, GitHub, pretty much all the socials. And I welcome you very much to abusing your CI/CD with machine learning. So without further ado, let me jump right in. I know we'll be on a moderately tight timeline. So a lot of you are probably pretty experienced machine learning developers, I would assume. I want to warn you, I am not. I play around with machine learning here and there. I use it where it's useful. I wouldn't consider myself an expert. I'm much more of an integration and DevOps-y type of guy. So, you know, bizarre and storied history there for sure. But as you can see at the very end, that's just really kind of where I've been playing with them over the last few years. So that said, I'm going to mostly stick to some very simple things on the ML side. This is a proof of concept. I'm going to more or less use linear regression in most cases, so excuse the simplicity, but I hope that there will be some useful things for you to learn about how DevOps and machine learning work together in this talk. So that's where I'm going to focus most of my time. By the way, I know that you're going to have lots of questions during the chat, during the talk. Go ahead and put those out there. I'll try to address them at the end. I may not get a chance necessarily to during the course of the talk. So DevOps itself, right, what is it? So for anyone who doesn't happen to be familiar already, development operations, really this is both a series of technical and cultural concepts that change how we do development, right? Some of you may be used to the old waterfall method if you've been in the industry long enough, right? Most of us nowadays are doing agile through in these fast iteration cycles, right? And to support that, we have a lot of technical components, things like Kanban boards, which allow us to do project management efficiently and asynchronously, collaborative code control like Git, which allows us to make changes to code and then issue a pull request and other people can come and look at it. Continuous build, test, release tooling. So that's a lot of where I'm going to talk about here and how machine learning fits into that. And then monitoring infrastructure on top of that. But it's not just tooling, it's also cultural, right? It's about having that mindset that the code I'm putting out there is going to be open, visible to my team, even when it's imperfect. We're going to have a collaborative approach to how we work together. And we're going to maintain a more or less egoless mindset to our code. We can put something out there that's imperfect and we can be okay with that. We're not our code. We are people who are trying our best and who can learn from each other and teach each other. And that's really part of the objective, right? So this DevOps mindset covers both of those. Now, when we look at a modern development workflow, there's lots of different ways to approach this, but for most people, it looks more or less like this. You spend a bunch of time planning and then maybe writing some code. But that code doesn't necessarily go right into the main branch of the project, right? You're maybe checking out some code that's already there, maybe something somebody else has worked on. You're making some changes to it, and then you're pushing that out there as a new branch, a new version of that code, but you don't immediately just squash it into the main line of the code. What you do is you create a pull request. You go out and you say, hey, everybody come look at this code, anyone who I want to have as a reviewer, let me know if you think this is okay to add into the product. Does it meet the needs that we spec'd out? Does it pass the tests that we expect it to? Does it meet our style guidelines? Is it readable? Are there massive flaws in it that could be a problem? If people more or less agree that it's good to go, then go ahead and you merge that. And that's when you move on really to the CI/CD portion of your development workflow, right? This is where automation comes along and it does the build for you and it runs tests against it for you. And this again is a departure from what used to be like 10 years ago. I remember in my first real professional position 20 years ago or so, we actually had one person who was responsible for all of the builds and tests. We would finish up our code, we would integrate it, we would walk it over to him on a USB stick, and then 2 days later, he would turn around and say, okay, code's good, it works the way we want it to, it passes all the tests, and now I'm gonna hand it to the next guy on a USB stick, and they're gonna push it out there, right? Nowadays, the world is very different. In a smooth operation, people merge their code in. Automated systems will compile whatever artifacts we need, run whatever tests we've created against that code, verify that it looks good. If anything fails, it's gonna break out and pass that back to us to make changes to and fix any errors before it actually moves on to the deploy process. And then lastly, you have an automated deploy, which then takes whatever we've created, whatever is passed, and does whatever is necessary to put it out there in the world, whether that's setting up infrastructure as a services and then deploying things out to them, whether it's building the Android and iOS versions of the mobile app and then putting those out to the actual app stores, whatever it is that needs to happen. And sometimes you'll have a manual gate in there where you say, okay, put the stuff onto a staging server, have a human review it as a very last check before you really put it out there in the world. Lastly, we have some sort of monitoring. So once our code is actually out in the world live, we have something that's looking at it actually running in production and just verifying that our hosts continue to stay up, our services continue to perform, and alerting us so that we can then react if something goes wrong and fix that. Now, when we take a look at this whole kind of end-to-end, there's a couple of things that are obviously out of scope of what we really want to talk about today. The planning and the actual coding, not really part of CI/CD. The hosting and monitoring, that's really about the platform we're running on. I want to focus on this middle box here, the version control service paired with the CI/CD. Now, you can have these as separate tooling, certainly. There's ways to get CI/CD standalone, right? Lots of popular things for that. But there's a few services that will do both of these all in one place, which is really convenient for developers because they are going along, you're writing your code, and then you want to deploy it or you want to see how the deploy process is going right there in the repo. You can just switch over to a different tab and see what's happening. There's a few different companies that provide that. Of course, I'm a little bit biased working for GitHub, and that's what I'm going to run this whole experiment on and demonstrate for you today. So we have the classic uses of CI/CD. So these are things that we're used to on a regular basis. You want to trigger on some change to a monitored branch. Somebody merges a PR. You're going to do some build process, creating your environment. Usually you're starting with a clean environment, pulling dependencies in, compiling your code, running whatever test suites you want against it. If there's errors, kicking it back. But there's some a little more esoteric things, like say checking for compliance issues, verifying that your licenses are all in line with what the company expects, that there aren't any exposed tokens, no passwords in the code that could be a problem if they leaked out into the outside world, right? Lastly, configuring that hosting infrastructure, if it's going to be, say, a web service, and then deploying it out to wherever it goes. So that's kind of what you know of as classic CI/CD. By the way, quick side note there, if you're interested in things like, say, checking for exposed tokens, check out that URL in the corner, github.com/features/security. And by the way, because I didn't mention it verbally at the beginning, let me also say that the slides for this are at bit.ly, bit.ly git.com/dev-global20, all lowercase. And that includes also a bunch of links at the end to the code repositories that I'm going to be working through here. All right, so let's get a little bit crazy, right? Let's see how we can fully utilize our CI/CD to do more interesting things, right? Preferably machine learning things, because we like that, right? When you look at CI/CD, really what this is it's a customizable abstract execution engine that you have that can be triggered from changes to your Git repository. That's super cool, right? You change something and boom, you've got a whole VM you can just play around with and do whatever you want. Now, sometimes there's limitations on just which operating systems you can use, how much memory you have, how much disk space you have, etc. But usually it's pretty good, certainly enough to run some very interesting stuff on. Now, you could use it in a very simplistic manner. Things like IFTTT and Zapier come to mind here, stuff that just reacts to one thing and then causes something else to happen. And it's true, you can do that. You could, for example, set up a webhook in your CI/CD so that some outside event, something like a Slack message, triggers the CI/CD to run, and then it does some other simple thing like send out an email to support saying, hey, this happened. But using it for just those simple little tasks, it's not always the best usage because, of course, there's overhead. If you're just doing a half-second task in your CI/CD, you're burning maybe 2 or 3 seconds spinning up that new blank environment, getting stuff ready and prepared to run, and then destroying it after, right? So really for simple stuff like that, I would still continue to use IFTTT or Zapier perhaps, or maybe a serverless function. I'm going to use this for things that are slightly more heavyweight. Stuff that I might not want to host an entire server all the time myself for. And that's where machine learning comes in, right? Because lots of us will build a model and then we'll have to stand up an entire server and keep it running 24/7 just to be able to serve a few occasional requests. But I can do something cool, like inject a machine learning model into my CI/CD. It only executes while the CI/CD is running, and then boom, the environment destroys itself, so I'm not getting billed anymore. I'm not burning up that extra compute. I don't have to be running something all the time. So this is pretty cool. And this is a great place where I really want that serverless functionality of I can spin something up, I can collapse down, we'll pay for it only when it's running, but that wouldn't work in a standard serverless function environment. If you've ever tried to do something like put a pretty heavy TensorFlow model into like a Lambda function, you know how very painful that can be, right? Many times it simply won't work. You have to go through a lot of backflips of creating your own zip file in a particular structure and uploading it. There's a size limit, so your models can only get so big. And there's an execution time limit that you often run up against when you're doing, say, batch prediction. So serverless functions work for some very, very small machine learning tasks, but not for many of them. So CI/CD really occupies that space in between having a simple serverless function that only runs when you need it and having a fully hosted server. It's that transit environment that can still be pretty heavyweight. And that's what I'm focusing on here. So I'm going to start with a really simple machine learning model. Again, I said the focus here is not the ML, right? The focus is what we're creating. So what we're going to do is we're just going to have a simple sklearn, scikit-learn linear model, right? I'm going to use linear regression here. I'm going to feed it a bunch of house prices and square footages. This is just stuff I pulled off of Zillow. I just took a whole bunch of properties and said, this is the square footage, this is how much it's being listed for. Obviously, this isn't a complete model. You wouldn't want it in a real world scenario because it's just got 2 variables and it's got a small amount of data, but it'll do great for a test, okay? So pretty straightforward. I read in that data from my prices CSV. I build my linear regression model, I fit it, and then I can utilize it for making predictions, right? So this is what I would do locally on my own machine. And I'm going to take all that code and I'm just going to drop it into a repo. I'm going to have that CSV. I'm going to have my training script I just showed you, and I'm going to have my requirements text that defines which dependencies I need, sklearn in this case, right? Now what I'm going to do, so I'm going to take note of that actions tab, right? So this is where CI/CD lives right next to your code inside GitHub. Every repo has an actions tab, and you can just click on it to get access to your CI/CD. You may not even noticed it. Go to your favorite GitHub repo right now that you own and see if that actions tab is there for you. You can start playing around. The first time you click that, what you're going to get is you're going to have a view onto the 3,500 or so prefab workflows that are already out there contributed by our community. And to me, this is one of the cool distinctions between GitHub and other providers, is that with other providers, you are going to wait for them to come out with the right integration component, or you've got to go out to whoever it is you want to integrate with, grab some custom code and kind of tool it yourself into your CI/CD environment, right? With the GitHub Actions marketplace, there's new ones being added all the time. So if I know that I say I'm building a Node app and I want to be able to deploy it to say Azure, I just go in there, I search for Node Azure, and boom, one of the things that's going to pop up is deploy Node.js to Azure Web App. I click on that, I configure a few things, and within a couple of minutes, I have an action which is going to run whenever I check in code or merge it to the main line, and it's going to simply deploy my entire application out to Azure, right? So that's one example of many. Now, in this case, I'm not actually going to make any use of any of those directly because I'm doing something pretty custom here. So instead, I'm going to click that Set Up a Workflow Yourself button in the upper right. Now, when I do that, what I get is a bare empty workflow. So this is a very simple hello world. This is what every action starts out as. Really, it's just a YAML file that's kept in a special folder, .github/workflows. And then each separate YAML file in there is a different action that I can execute, right? Each action has a few different parts. I'm going to step through exactly what those are in just a minute. What you see on the right there, by the way, is the documentation. So I'm starting to create a workflow here. I'm like, how do I do it? Well, the documentation is right there next to me, and I can start looking up whatever it is I need to do inside that documentation. And while I'm looking at that, I might notice, oh, hey, what about the environments I'm allowed to run, right? So I can see that there's a runs on entry inside the workflow, which basically defines which environment I'm going to be executing on. I'm certainly used to having Ubuntu. I'm occasionally used to having Windows available as a runtime environment, but Mac OS is fairly unusual. And so I'm going to give this a little twist and do something fun. So any of you who are iOS developers, you may have come across this already. Apple has a framework called CoreML, and CoreML only runs on iOS and OS X. It doesn't run on any other operating system. So this presents a problem for people who are developing, but they want to be able to test what the actual predictions are going to look like. They may not have an iOS or OS X based device. They might not own a MacBook or an iPhone. And this comes up surprisingly often because, even though the initial developer might have, someone else who's, say, vetting the code or who's responsible for your DevOps might not, right? So how can they actually test that this will work without one of those physical devices? And that's where having an OS X runtime environment right in your CI/CD is kind of cool. And I'm going to make use of that because why not, right? So what I'm going to do is after building that scikit-learn model, I'm going to make use of the CoreML tools provided by Apple, and I'm going to convert that sklearn model into an Apple CoreML model. And I do that by just using coreml.save, and that serializes out my scikit-learn model that's in memory as a CoreML model that'll run on an Apple operating system, right? And then I just print out the fact that I saved it. So that's just what I'm adding to my train.py for actually creating this model and then serializing it out. Run locally, that would be on disk, right? Now, I'm also going to write a predict.py, and I'll show you what this looks like in terms of what you do, right? So pretty much the same as you might have done with other machine learning models. First, you're going to deserialize the model from disk, and with Apple ML, you do that by just calling ML model and giving it the file name. And then what I'm going to do is I'm going to read from a file called input.csv. So you saw my training data. Input.csv is just simply a list of square feet of the houses that I might be looking at that don't have prices yet, and I want to predict what those prices should be, right? I'm going to read through that, and then I'm going to write a file called output.csv, and I'm going to run the prediction for each line of that, and I'm going to write the results all to output.csv. So pretty much all I do here is if I've got a file input.csv on my machine and it's got a list of square footages, I run predict and I get out my output.csv, which contains all of my predictions. Pretty straightforward, simple stuff, right? So let's get interesting with this. Now what we're going to do is we're going to take this And we are going to actually put this into our actions. And what we do is we create a workflow with these parts I'm going to walk through here that'll actually execute these scripts whenever files change. So the first thing is I'm just creating a new YAML file right inside that .github/workflows folder, the one we saw through the create actions interface. By the way, you can use that create actions interface, but you can also just push a file to this location in your repo and it'll start getting picked up by actions and running. Give it any name you like. That's just a label that's going to show up in the logs. And then tell it when it should run. So on then can have as many triggers as you want. One of the most common is push. Again, this is all in the documentation, but push simply takes a set of paths that it should watch. And if somebody pushes to one of those paths, then this is going to execute, right? So if I go and I update, say, my training data by editing prices.csv, then this action is going to be triggered because it'll see that change to the file on the main line. And I could restrict specific branches if I wanted to. And then it's going to move forward. Next, I have a list of jobs, and I can have as many different jobs as I want. I can tell each one what operating system it's going to run on, and I can have more than one operating system here if I want. So I can actually be doing parallel builds on multiple operating systems if I so desired. Also, I get to define some other things about the environment. I'm creating here what's called a matrix build. Now, right now, it's only got one element in it, but I could specify there more than one Python version by just adding to that array. So I might do 2.7, 3.6 if I wanted to test it out on both Python 2 and Python 3, for example, right? And what that would do is it actually spin out, again, parallel environments, so that it'd be running at 2.7 at the same time it's running a 3.6 environment. And I can specify what level of parallelization I want or whether I want them to run serially by just specifying that max parallel. The nuts and bolts is simply that for every operating system I've specified and every Python environment I've specified, I'm going to get that cross product. So, you know, I might say Ubuntu and Mac OS, Python 2 and Python 3, and that's going to spin up 4 separate environments, each of which is going to do the rest of the steps that follow. All right, so moving forward to those steps, you can have as many as you want. And here's what a typical one might look like and what I'm doing here for my machine learning model. So first, I have to check out the repo itself because I basically spun up a brand new environment. It's blank, right? So the first thing I'm going to do is I'm going to check out the code from the repo that this is running under into that empty environment. So I showed you all of those actions that were in the marketplace before, and you can use one of those wholesale, but you can also include them in your custom action script. So that's what I'm doing here. There's one out there called actions checkout, and I'm using V1 of that particular action as an inclusion to this action that I'm creating. And action checkout is pretty simple. It basically just says, hey, whatever repo I'm running under, go and check it out and get all of those files and pull them into my local directory, right? Since this is triggered by an action which requires credentials, push, it means that those credentials are available to the environment. So I'll show you actually down at the bottom, there's something called secrets.github token. That's an implicit value that's set in the environment. I don't even have to worry about it. It's the credentials of the person who triggered this workflow, who actually did the push, that allow for that checkout and other things to occur that have to be privileged in the GitHub environment. Next step is I'm going to set up Python. And again, I'm just using somebody else's actions for setting up Python. So they've pre-scripted this thing where you tell it what version of Python I want to run, and it just sets it up and configures it for you. And then lastly, I'm going to run a series of shell commands. Now, this is pretty straightforward here. I'm going to pip3 install my requirements.txt. So now, boom, scikit-learn is available in my environment. And next, I'm going to run Python again and call that train.py. And that'll actually go and do everything we just saw. It'll go ahead and create that regression model, and it'll save it as a ML model file. Next, since I've just done a training, I might as well run my initial set of predictions. Boom, now I've got some output there available inside my local file set that's running in this environment. Lastly, what I want to do is I want to take that model that I created and the predictions that I just created, and I want to commit them back to the repo. So that's what this next step is simply configure my local Git. It just needs email and name specified because for some reason those aren't automatically defined in the environment. But after that, it does the commit and it just uses that GitHub token secret when it does that push down at the bottom to actually push those files back in. So what this means is right there in my repo, I start out with some basic files, my input, my prediction script, my initial prices for training, my requirements, and my training.py that we all just saw. Those are the only files in there. I'm then going to go and I'm going to say, edit the prices.csv, and I'm going to commit that. That causes a push to occur. Actions notices that, runs all of the stuff we just saw, creates those outputs, and commits them back to the repo. So then what I see is if I actually swapped over to that Actions tab, I could view it and see the log of what's actually occurring. Most of the time, I don't care about that after I've got it set up, but it's great for debugging when I'm first building my action script and want to make sure it's running right. I can see each step of it. I can break those out and see all of the lines that actually execute, how long they took, that sort of thing. If there's a failure, it'll actually email me to let me know something went wrong. So once this is up and running, I just get notified if anything ever breaks, yada, yada. After it executes, I see those two new files there in my repo, the output.csv with the results and the model that it created, of course, to do those predictions for me. And you know what? Maybe we don't always just want to run this when, say, the training data is updated. Maybe we want to make it possible for someone to, say, just update the prediction, rather the input CSV, and just get new predictions out, right? So no retraining is needed at that point. So it's a slightly different workflow, but the syntax is basically the same. Hey, I'm going to create a second workflow just for noticing predictions. It's going to run when, say, the input data is changed, but this isn't training stuff. It's just for the predictions, right? It's going to set it up. It's going to check out the text, the code. It's going to install just the dependencies, in this case, we need for predictions. So I don't need all of scikit-learn. So I'm not going to run that requirements.txt. I'm actually just going to install CoreML tools, the only thing needed for prediction, right? I'm going to run the predictions. I'm going to commit the output back, and there you go. So same thing. Someone can come in. Someone with commit permissions to your repository can just say, hey, change the input.csv. And it'll execute behind the scenes without them even seeing it. And then they're going to get a new output CSV. So now what used to be having to explain to someone where this API endpoint is, or give them a model that they need to run locally and then have them set up, now it's all reduced to simply, okay, you have permission to commit a file to this repo. Boom, do that, wait a couple seconds, you get back your results, right? So that's super useful just as a sort of ad hoc thing. Now you no longer have to have a specialized place to deploy your models. You can just put them up in a repo and your compatriots, your collaborators can come along and just get predictions out of that, no problem. So that's one possible use. But there's lots of other things you could do with this, right? Like you don't just have to make it available for other people to use. Models can be a core part of other things you do. So to give you an example, I have a friend he runs a repo that basically creates a website that is just sort of it's a journalism website, and then of course there's a bunch of images, and he wants to optimize those images with a machine learning model that he has built, right, for reducing the size and increasing the clarity of those images. So he's created an action which simply looks at the repo, and anytime an image is submitted to the repo, it runs it through the model, reduces the size, makes it cleaner, and then commits it right back into the repo. So what this means is he no longer has to worry about pre-optimizing any of his images or anything like that. It's going along. He and his collaborators are all just creating content for this website. They're pushing it up to this repo, and the ML models required to do all of the image reduction just occur invisibly in the background. So a few other caveats here, other things you could do. First of all, so it doesn't just have to be push. You could do this on a scheduled cron. You could do it with your webhooks. You could do it with an API call. If you have a project board hooked up to this, you could even cause things to occur in your CI/CD based on changes of state of issues in that project board. So there's lots of different cool APIs. Also, you don't necessarily have to have the training data right in the repo. You could be pulling that data from somewhere else because, again, The action itself is just an execution environment. So maybe you connect to a database to pull in your training data and create your model that way, et cetera, or scrape it for some API. And lastly, you can, of course, call other APIs. So, maybe I'm doing something interesting, like I'm running that optimization of the images, but then I'm also pushing them out to a CDN via their API, or I'm executing a code quality API against that repo to make sure that all of my code is really safe and looks the way I should. So all kinds of cool options there. I'm going to skip over this bit. It's in there. Summaries of how many free minutes you get and all of that. You can find that obviously on GitHub. I will say a couple of quick things. First, the terms of service, this really isn't supposed to be for serverless computing, as I said. Use this for things that are appropriate to your actual workflow. It really wouldn't be efficient for just ad hoc, single serverless style calls. It would be better handled by Lambda. Also, if you're just doing singular predictions, I would encourage you to go and take a look at algorithmia.com, actually my prior employer, but what they do is they specialize on just machine learning model hosting. So it's not a full CI/CD or anything like that, slightly different purpose, but if what you're doing is like lots of ad hoc singular predictions where you don't want to deal with that overhead, but you just want something better than say Lambda in terms of its capability, Algorithmia is great for that. The last thing I want to add on here is GPUs. Right? So everything that I've shown you so far runs inside GitHub's servers. All of those specifications for Ubuntu, Windows, Mac OS, etc. Those are different configurations that GitHub has. So you say, I want to do something. When the action spins up, it spins up in one of our virtual machines, executes, sends it back, right? That's where all these minutes per month and everything apply, right? But if you want to do something a little bit more complex, you can use a self-hosted runner. And this is where I'm going to get kind of fun. So I've got a Jetson Nano given to me very kindly by NVIDIA, which wanted me to play with this dev kit, right? The cool thing about the Nano is it's actually got GPUs on it. So I'd love to make use of this somehow. And I have that sitting actually across the room from me at my desk. I want to be able to hook a GitHub action into it so I can make use of the GPUs on that to do some deep learning models, right? But I still don't want to have to build lots of glue. I still want the action CI/CD syntax, the YAML files, all of that to run the way I just said. Fortunately, it's really easy to hook in. So what you do is you go into your repo, you go to the settings tab, and you find the actions section. And then you'll see that there's an option there for self-hosted runners. And I just click that add runner button right there. What it then does is it gives me a script that I should just pull down and run on my local machine. So I did that. I copied the script from here. I ran that on my Jetson Nano and it configured itself. And now it's got something sitting there listening so that anytime actions says, hey, I should use this particular runner, that server basically will respond on my Nano and make use of all of the hardware capabilities of that device. Then I go into my workflow, and instead of using runs on Ubuntu, Windows, OS X, I say runs on self-hosted. And that tells this particular action to, instead of running on one of GitHub's prefab VMs, to go find that self-hosted runner, the Nano that I just connected, and execute on that. And then come on back, right? All the other syntax is identical. So what I did just to test this out is I made a quick little script. Again, this is just to test it out. Obviously, I'm not doing anything mind-blowing here. I'm just basically saying, hey, can I actually do something on a GPU? This would fail if I executed it on any of the default GitHub hosted runners because those don't have GPUs, right? So I'm just going to create an array. I'm going to call GPU array to GPU. I'm going to run pow on it, and I'm going to get the results, thus proving that I've actually executed something on a GPU, right? Go ahead and I run that. Same exact thing. I can see the output right there in the Actions tab with all the logs. But if I go over and I look at the actual screen of my Jetson Nano, I'll see right there it was listening for jobs. And then it got this job it was supposed to execute, it ran it, and it sent the results back to my repo. So pretty cool. I've now used all of that GitHub Actions machinery, but I'm executing on whatever custom hardware I want. And that could be a physical device, but it could as easily be something like an Azure machine instance that I've configured that I have running for some other purpose most of the time that has GPUs, but I can also add a self-hosted runner instance into that, so that machine can now have dual use. It's doing whatever it normally does for serving, but by the way, if I ever run an action that needs a GPU, it's just going to boom, go hit that machine, execute there, and put the results back into my workflow. All right, I've just about come up on time, but we have, I think, some questions sitting in the chat. So I'm going to leave you with this screen, hopefully, and please feel free to go and grab this presentations, bit.ly/devglobal20, and that code there at github/pecjon/CoreML_GH actions. You can clone that and do everything I just showed you right here and test it out in your own. If you have any problems or anything, feel free to reach out. And again, PeckJon on Twitter, LinkedIn, GitHub, feel free to hit me there. And with that, I'm going to step over to the questions window, and Roxana here, I'm sure, is going to help walk me through this and see if any questions have come up, but I'll try and skim through as well.
Thank you so much, Jon. So it's actually one of my first sessions to moderate where the compliments are more than the number of questions. Either it's silent, but this time
Thank you.
I'm blown away versus very cool, awesome presentation far exceed the number of questions. But one interesting question was, what's your take on how GitHub CI/CD offering compares to GitLab's?
Yeah, absolutely. That's a great question. First of all, we both occupy slightly different places in the market, right? GitHub has both a community offering and an enterprise offering. GitHub's community offering, one of the things I say about it is it's really, as much as it's about the functionality, it's about the community behind it. One of the things that I really love being here at GitHub is seeing how many developers we have utilizing our platform, and that really changes our product direction. Because every time someone comes along and says, hey, there's this problem with this feature that's not needed, we have enough community out there that we can see there's a lot of people who really want it. We can test it out and say, hey, does it play the well it should, how it should with our customers? Do they really like that? And then bring that back in as a feature that we know that's already been proven to be useful to our community. The other thing is the strength of the community behind it. So like I was talking about with those 3,500 community contributed actions that are out there, that's really kind of a number that other companies, whoever they happen to be, can't boast, because they just don't have that huge community behind it contributing all of these things. The third is I don't want to sort of sound too salesy here or anything. That's not my purpose here. But I will say that there's a lot of very cool stuff coming out of GitHub. That's really kind of first in the market, really best in breed stuff. You look at how security, for example, ties in to our repos. That ability to commit code and, for example, within half a second in an enterprise environment, if you've put an AWS token out there and exposed it in your code, boom, that token has been revoked from AWS so that it won't have a possible effect out there in the marketplace. Or when you commit code out there and there's an insecure dependency, getting a pull request right away that says, hey, this is the minimum patch version you have to create against this dependency to fix everything. Those kinds of add-ons, I think, really make it invaluable. And in a lot of cases, those are the part of the base product. They're not things you have to add on and pay for separately. So they're super powerful for our community.
Thank you for that. So Relove just posted an interesting question now. We're deploying a model as a service, and one of the challenges is faced with integrating trained models with the API. Can we use GitHub as a repository for the model files, Pickle? And how do we deal with the large size models?
Right, absolutely. GitLFS is certainly your friend there for large file hosting. So that's certainly one way to handle it. place that you want to think about with those models is, first of all, exposure and meaning, right? So do you want that particular version of the model you have built to exist inside your repo for a number of different possible reasons, right? One is, is it okay to expose that built model to all the people that are using the repo? So that's your first question, right? The next is it meaningful in its transient state? A lot of times you're building a model that's going to be identical every single time you build it. If you know the version of your data that you're pulling it from, if you know the exact version of the dependencies that are being used to train that up, and then serialize it, then it's completely reproducible. And you don't necessarily have a reason to actually store that particular transient copy of the model in your repo. Okay, so that's one answer. If you do have a reason, GitLFS is your friend. In addition, you could also do something in between. Because Actions is just an execution environment, you could put a sideband attachment of any file storage you want on there. You could attach to an Azure Drive, for example, or to blob storage in AWS. And you can push-pull out of that blob storage just as you would from any native environment, right? So a third possibility is simply that you do all of your prediction and building. It's all right there inside, say, Actions, but the actual storage of those artifacts that maybe don't need to be part of the Git repo itself can still be sidebanded onto some other file storage.
And we have another question that just came in. How do you recommend model versioning integration with GitHub Actions CI/CD?
Right, absolutely. So I think, yeah. So I think part of its answer there, like you could use GitLFS and you can do versioning on top of that, to my knowledge. Another thing is, you might want to think about how you're versioning your source data, right? So if something is completely reproducible, really that's dependent on the version of the source data as well as the version of the code that it's executing on. Right, so that's something you want to think about is having those artifacts have metadata attached to them where, say, I build the model, but then I also build out something, it may even just be a text file that lives next to it that says, hey, it was this version of the data that I used, probably like a timestamp, some kind of representative hash, that sort of thing, and the list of exact dependencies I used and that sort of thing, or a hash representing the code at that point in time that was used to execute it, right? Just the Git hash. So that's another way to do that. Again, if you're sidebanding, just keep that next to it inside your sideband storage.
We had a question that I think you mostly addressed, but just in case, what kind of servers are available behind the Actions? So like,
right, yeah, so you've always got OS X latest, Windows latest, and Ubuntu latest. Right, and I think those are exactly named like that, Mac OS latest, right? And that's just basically a step behind whatever's the current production version of each of those. And we have, scheduled releases that we announce of like when we're upgrading to each one. That said, you can also like past versions, and we keep quite a few of those around, but to get the full extensive list, you'd have to go to github.com/actions and read what it currently is. I don't have it all memorized, unfortunately. And by the way, that'll be the same answer for, I saw there was one that rolled up about, what's the memory, what's the disk storage available for each one. Again, sorry, it's not all in my head, but github.com/actions, and you should have a table right there that shows it all to you.
Perfect. Can the push or trigger be from another GitHub repository?
Yes, absolutely. And that's where webhooks come in really useful. And I think there's also a specific action for tossing from one to the other. I forget the name. But yeah, it's pretty straightforward. You just have to have, whatever that user identity you're running under, you have to have permission to call the other one as well. If that's local, obviously that's not a problem. Otherwise, there's ways to inject secret keys and that sort of thing into the environment for you so that you could have, credentials being proxied along from one to the other. But yes, you can basically sort of, call one action. You can have as many steps as you want in that, but maybe at one point then you want to make like a webhook call to another action and trigger that, or even have a sort of map reduce kind of approach to what you're doing if you want to call out to mini branched actions and then reduce the results back inside the main action. That's entirely possible. It's in code. right now. You still have to write your YAML file. It's not too bad. But we don't specifically have a sort of like Zapier or IFTC like UI for that yet.
Yet being the keyword. Nice. So I think that concludes our questions. I would like to really, really thank you and our attendees, and not just for the presentation, but for staying quite a bit over time to address all of the questions. It was enlightening for me. I have a lot of learning to do.
It's a super fun world.
Definitely. Thank you so much. It was a pleasure.
Well, thank you. Really appreciate it, and appreciate everyone who stayed on. Love talking to you today. I'll close up my video, but I'll actually hang out on the chat for just a bit, see if there's any lagging questions that I can answer over text.
Perfect. And
Thanks
someone was saying the links weren't clear. So remember, you can just access the slides and then you'll get them directly. And just remember, you can just join the Wahoba app, and then there's lots of really cool things there, from job postings, code papers with code, everything. See you all soon. It was a pleasure.